If you're new here, I'm Kimberly. I created the autism and the comorbidities hypothesis of genetically induced allostasis and the BH4 shunt. My hypothesis was recently plagiarized and peer-reviewed in Brazil. So let's start with what is a genetic condition. Our genes carry the instructions for making something called proteins. Each gene carries the instructions for making one specific protein and different flavors of that protein to handle different conditions. Your body is essentially a really complex conveyor belt system made of a whole bunch of them. Together, they work to keep you functioning and healthy. These proteins work very lock and key. So in a genetic condition, if the instructions are not written down properly, it can't do its job. The outcome of which is predictable based on the function of whatever protein that gene codes for. Now let's talk about neurodivergent biochemistry. Our body's in a constant state of trying to maintain balance or homeostasis. And there's a specific set of proteins that are constantly activated in the body to maintain that balance. There are 5 different epigenetic biotoggles that can knock your body off of balance into a state called allostasis. It's essentially turbo mode where your body's trying to restore balance. It has to work a little extra. These 5 toggles are the immune system being triggered, metabolites being off, cellular repair, the nervous system being triggered, and genetic regulation. When these scales are tipped, it turns on a different set of proteins. I call them allostatic proteins. And their job is to restore balance in the body. This is the science behind epigenetics, why your genes turn certain ones on and off in certain situations. They are meant to be flipped on, utilized, and balance restored. The problem becomes when they're stuck on or locked on because of genetic conditions. This is my hypothesis around autism. There's a gene mutation that leaves the body in a chronic, permanent state of allostasis, where these stress proteins, allostatic proteins, are constantly being made. When the homeostatic proteins are functioning appropriately, the body will typically develop and typically function. However, when you have an allostatic state of existence, these allostatic proteins disrupt that process. They're prioritized over the homeostatic proteins. Your body does this as a survival mechanism. However, the outcome is atypical development and atypical function. And when it's an allostatic existence over a lifetime, something called allostatic overload happens, which is wear and tear on these processes, leading to the comorbidities. So that takes us all the way up to here in my chart. Those are the redox protein shifts, leading to impact on fetal and child development over time, functional impact across the lifespan, and allostatic overload. The BH4 shunt was the first redox protein shift that I saw because it's the most impactful. That is the linchpin of our immune system. Because BH4 is regulated by cellular stress, and each of the 5 BH4 dependent pathways are involved in the biotoggles themselves. The immune system shifts so that it can handle whatever the source of cellular stress is and get rid of it. The nervous system changes which neurotransmitters are produced because the body needs to communicate differently so that it can restore balance. And metabolism and cellular repair shift as cellular demand shifts in that turbo mode state and repair state, leading to autism and the comorbidities, mental autoimmune and endocannabinoid lipid comorbidities.